the next question, which is about mechanics. Now, as we are learning about environmental geomechanics, and then in it we have topics like soil mechanics, rock mechanics. So, but what do we understand by this term mechanics? So, this again has been explained in the lectures that what is mechanics. So, mechanics, so these are four options. So, first is the patterns of response of material. So, in mechanics, we know that we are going to learn about rock mechanics and soil mechanics, let's say. So, how these materials, which is rock and soil, how they are responding to different type of situation or different type of environmental factors. So, if there is, let's say, if there is weathering, there is physical weathering, okay, so there is, or there is chemical weathering, how they are behaving, how they respond, how the material is responding to the change in the environmental factors, right? We study that definitely. Next is behavior of material. It is similar to the previous one, that how the material is behaving in different situation. Another is about the quantification, that is the material, soil or rock, they are responding to different situation differently. As I discussed previously as well, that uh, two if let's say similar type of rock are present in different environmental condition, they behave differently. And so let's say we have one type of rock here, one type of rock here. Here the temperature is high, the pressure is high, and here the temperature is low but the pressure is high. Now the and it's same type of rock, but the property of this rock is that it can withstand high temperature and low pressure. It can withstand high temperature, but it cannot withstand low temperature. So sorry, so it can withstand it cannot withstand high temperature, right? So so it means that in a condition where the temperature is high, this rock will decompose or will decay or will weather. On the other hand, in this condition, there is not much effect to this rock. Hence, so what we measure is that how much the material is responding to the change or to the environmental condition. We can create the similar condition in laboratory, we can have the similar condition in the nature as well, and we can quantify that how the different material are responding, right? So these three are the answers. So now we move towards the contaminants. So which of the following is true about the contaminant in a geomaterial? So, what do we understand by the term contaminant? Contaminants is anything which is foreign body. It means it is unwanted to the soil or rock or water or any geomaterial. So, it is. It means so this contaminant can be two type. Okay, so it can have a positive effect. Sorry, it can have no effect. It means it is there, it is neither helping the soil not harming the soil. Or it can have negative effect. It means it is harming the soil or rock or any geomaterial it is present in the case when there is no effect, we don't much care about the contaminant. But when it is negatively impacting the geomaterial, we have to think about how to tackle the contaminants. So, first is yes, they are unwanted substance. Another is that does its fate in the porous media always need to be ascertained? It means that do we always have to understand how this contaminant or this foreign substance is going to affect The substance, yes, because uh, let's say, in a very simple term, let's say we have a landfill site. Okay, so this is uh, this is soil, and here lot of um, um, waste is being deposited every single day. Now, we generally tend not to segregate, so there is no as such policy of waste segregation. So, in many places, the waste, irrespective of it has batteries, it has plastic, okay, it has acid, irrespective of that, acid in laboratory there is a different method of uh, to deal with it. But in general, the acid that's present, let's say in the batteries, the inverter batteries, and everything. So this soil has a lot of these heap of substance. Okay, now this battery has lead as well, different harmful metals that can seep into the soil over time. This plastic again can seep into the soil after degradation, can harm. Also, along with that, any other chemical, let's say any acid that is present or formed because of reaction, maybe because you don't know what is there in the waste, right? Because you see, in many times they actually catch fire. There is a reason that the landfill many times catch fire. It could be, of course, because sometimes because of heat as well, but there the reason is because we don't know what we are putting into the landfill. There is like different material, and many of them are harmful, like, so all of this bad material is seeping down the soil. So first what it is doing, it's harming the soil. It means that this landfill soil, or this land on which we have this heap of waste, it is basically very polluted. And through this, it is, so it means that is in this soil there is no good mineral, right? There is no good quality, so minerals are degrading, the organic matter is degrading in this soil. Now this material can also seep down and can also contaminate the groundwater, and hence affect all of us because we use groundwater. So whenever we see that there is a contaminant in a geomaterial, we need to understand that how it is going to affect the porous media, that is soil or water, or the soil or rock, etc. Another is always detrimental to the porous media. It's not always. Sometimes, yes, it is detrimental to the porous media. It means that it affect sometimes, uh, but it means that it, uh, sorry. So it is not always detrimental to porous media. In some cases, yes, it um, it leads to this, but in many cases it might not be detrimental. So the answer is B. As answer is D. Now the last is about the saturated geomaterial, which is about the what can a water submerged geomaterial be treated as saturated. So when we what do we understand by the term saturated? Saturated means that it is completely filled with any material. So in this case it's water. So saturated means that the geomaterial is fully, it means that it is so filled with the water that there is no any more space to be occupied by water, right? But the question is that if, let's say, there are two, in this water is filled. Now if we put two geomaterial, let's say rock, and we completely immerse them in water, So does it mean that they are fully saturated? No. In some case it can be. Okay, if the rock or the material, so if the rock is very porous, for example something like pumice rock, which is a highly porous igneous rock, or it is another material, for example it is soil, uh, because soil has higher, more amount of pore, but is still not fully saturated. In a case of rock, for example let's say granite, so generally what will happen is, because there is no pore space, because the matrix is so compact that you can only see the outline of this granite to be covered with water, and there is no uh, seepage through it to the inside of the granite. And that is why it says that the geomaterial, even if it's submerged in water, there are situations when it can be saturated, and there are situations when it is not saturated. So answer is no. So thank you for today. We'll meet in the next session.